And I guess we'll get started. My name's Scott Unger. I'm a forecaster here with the Nashville National Weather Service office. And you are here for tonight's installment of Weather 101 called Observations in Upper Air Patterns. And we're going to be taking a look at things in 3 dimensions this evening. So what I always like to tell folks before this class is that I'm going to want you to get out those imaginary 3-dimension glasses that you would get at like the movie theater. And we're going to start picturing things in 3D here. So we'll start at the surface when it comes to the 3 dimensions. And we'll talk about the ins and out of Metars. I'll cover what a Metar is. How are they used? And then at the end, we'll start talking about upper air patterns and answer the question, why are some storm systems stronger than others? So we'll be here for about an hour. And if you got any questions throughout, up in the top right-hand corner of your screen, there's a little kind of icon up there. There's a chat that you can type your question in if you want to do that, or you can raise your little hand. There's a little hand up there, and I can try to call on you as we go through and try to answer any questions that you might have as we go through. So, all right, so let's start with Metar. And first we got to say, what does Metar stand for? We've got so many acronyms in weather, and this one is probably first and foremost. Metar stands for Meteorological Terminal Aviation Routine. You can see how the letters are underlined there at the top in black. Or it's also a Meteorological Aerodrome Report. Minimally once an hour, at the top of each hour, the ASOS, or the Automatic Surface Observation Stations that are located at just about every airport across the country, give us these Metars. They are reports about what's going on at, what's going on at the surface, what the current weather is at the airport, and what kind of cloud cover is over the airport. They're used very heavily in the aviation community, but they're just one piece of a bigger puzzle for us as meteorologists. So Metars come in a couple different forms. First off, they come from the Metar in this raw form. That's what you're looking at here. All right. These are from the Nashville airport, as by the identifier that's on the left-hand side. So let's go ahead and zoom in on one particular raw Metar out of that group. And I'm going to break it down for you so that you can read it. So the first thing that you see on the left-hand side there is the station identifier. Almost all of them start with a K, and then the next 3 letters or numbers identify the airport. So let's say ATL would be Atlanta Hartsfield. All right, KATL would be Atlanta Hartsfield. Here in Middle Tennessee, KBNA is Nashville. BNA being Nashville. Up in Clarksville, KCKV is the Clarksville airport. Next, is the date and time stamp for the observation. The first 2 numbers are the date. So this is for the 18th of the month. That's what's right above the red line there. And then the next 4 numbers is the time in UTC. All right, above the blue line there. That's the time in UTC. UTC, or Z for Zulu. All right, it's another name for UTC. And I'm not going to take the time to explain how this works. You can easily Google how to kind of translate back and forth between UTC time and local time. All right, the next grouping is sustained wind speed and direction. The first 3 numbers are the wind direction. So what you're looking at above the blue line there is 190. So the winds are out of basically the south. 180 is directly south. So this is a little bit west of south. So west-southwest. The second 2 numbers are the sustained wind speed. All right, so 09. So this is 190 degrees, the wind's blowing from 190 degrees at 9 knots. And winds on these are all done in knots instead of miles per hour. The G stands for gust. And then 17 is what the gust is. So it's out of the west-southwest at 9, gusting to 17 knots. Next part is, visibility. And this is, that you see here is 7 statute miles. That can range, if it's perfect visibility, you're going to see P6SM. All right. Could see 10 SM as well. Those are two equal values. But this is where it's telling you about fog. Okay. Visibility is talking about some impairment for your ability to be able to see far off in the distance. Then you have present weather. This particular example, this minus RA means light rain. If it was just RA, it would be moderate rain. If you had a plus out in front of it, it would be heavy rain. So in this particular example, there's 4 ceilings or cloud levels. Some airports have a slightly different equipment from others. Out at the Nashville airport, they actually have 5, the ability to be able to detect 5 cloud levels. Few means a certain thing as far as how many clouds are in the sky. Few, scattered, broken, overcast. Those are the categories, and I'll break those down here in just a little bit. But the way these are read is, in order to see what the actual height of each cloud level is, you put 00 at the end of each of those 3-digit numbers on there. So for that first grouping, that first level, there's just a few clouds at 3,800 feet. Then the next level up would be broken deck at 6,000 feet. All the way over to the OVC, or overcast. And if you put 00 at the end of that one, that's an overcast deck at 13,000 feet. So that's how those are read. Next group is temperature and dew point. And in the raw Meetar, these are done in Celsius. So that 20/16, that's in Celsius. Again, an easy conversion can be found just by Googling Fahrenheit to Celsius or Celsius to Fahrenheit. And then the rest of this is for aviation purposes, and we're not gonna cover that stuff for today. All right, so I got a poll question for you. It should pop up here on your screen in just a second. And let's see if you guys caught what I was talking about when it comes to wind. Wind direction is always described as the direction the wind is blowing or the direction from which the wind is blowing. And while you guys are answering that, Ben asked, are rural airports included in Meetar reports since there is often great distances between the larger ones? Yes, Ben. You'd be able to get raw Metars for any airport that's got an ASOS at it. So even the rural ones too. Shelbyville down in southern Middle Tennessee, Tullahoma, all those, Lawrenceburg, all those little airports have ASOSs on them too. There's only a few that we here in the Weather Service office here in Middle Tennessee are responsible for as far as the equipment goes. We do Clarksville, Crossville, and Nashville. And then all the other ones are other government entities or local entities that are responsible for maintaining the equipment out there. Okay, so I'm going to share the results, and good. Just about everybody picked up on what I was talking about. And wind direction is always described as the direction from which the wind is blowing. So with our example that we were looking at there for the raw Meetar, 190, that's the direction from which the wind is blowing. All right. Right. So from the raw Metars, we take the raw Metars and then we plot them. We plot them on a map. They're done all across the country, and this example here was from earlier this afternoon, and while it's not all of the ASOSs across the southeastern portion of the United States, it's a good portion of them for us to be able to look at this, use this to create a surface analysis that we'll get into in just a little bit. I'm not going to go into a full-blown analysis, but I am going to break down what a surface map analysis would look like. But let's zoom in on one of these plotted Metars and break down what the different parts are that you're looking at here, because you may have attended one of our advanced classes, and one of your presenters might have talked about some of this stuff when we talk about a particular event. And so we want you to be able to break down what these different Metars are telling you. So zooming in on one, and I made this one up just for purposes of ease when it comes to in PowerPoint here. But same thing is just gives me an opportunity to be able to break down each one of these parts here. So let's start up in the top left-hand corner. The first one that you're looking at is the temperature in Fahrenheit. That's up in the top left-hand corner, and that's in red. Now remember, in the raw Metar, that's done in Celsius. Here in the plotted Metar, it's automatically converted over into Fahrenheit for you. And you've got the dew point in Fahrenheit in the bottom left, and that's in green. Again, that's converted over. Before I go real quick about the difference in the comparison of the environmental temperature in the red and the dew point in the green, the dew point is never going to be higher than the temperature. But as they do get closer to one another, this illustrates relative humidity in the atmosphere. So if the dew point is the same as the temperature, it can be the same. That's 100% relative humidity, and it's likely either raining or there's rain in the area. All right, dew point can never be higher than temperature. All right, top right-hand corner of the plotted Metar is the surface pressure in millibars. You might know surface pressure from your local TV meteorologist as inches of mercury, and it's just again, it's a unit conversion from inches of mercury over to millibars, and in the meteorological community, we just use millibars. If you take the upper air class of Weather 101, I think later this month or in December, you'll learn more about millibars and why we use millibars in meteorology. So how do you read this one? All right, so if the pressure starts with a 0, you're going to put a 10 in front of it. So for this example, this pressure is 1,000.2. If the pressure starts with a 5 through a 9, you're going to put another 9 in front of it. Now, there are some examples that are kind of crazy out there. But when you're doing a surface analysis, you're going to look at the sites that are around the one that you're trying to figure out what the three digits are going to read, and you're going to kind of interpolate what a particular number is. So in general, if you see a 0 at the beginning of these three numbers, you're going to put a 10 out in front of it. It's going to be 1,000.2. And if there's a number of a 5 through a 9, you're going to put another 9 in front of it. All right, so an 823 display up there would be 982.3. That would be the surface pressure in millibars. In the bottom right-hand corner is the station identifier. Now, this doesn't have a K in front of it like the raw Metar did, but the BNA would stand for Nashville Airport. And then the wind barb. Okay, and you got to think about the wind barb as an arrow that has little feathers on the end of it. All right, so the arrow The wind isn't, or your arrow wouldn't fly through the air with the feathers first. It's going to fly through the air with the point first. So the wind barb is pointing in the direction that the wind is blowing. But it's red, just like earlier when we were talking about the 190 from the raw Meetar. It's red in this example would be about 120. All right, so it would be 120 degrees, the direction from which the wind is blowing, 120 degrees or southeast. The wind's blowing out of the southeast. And then the little arrows or the little feathers at the end, this is how you decipher those. So a long line, and they're not going to be yellow and green on the plotted Meetar map. I've colored them so that you can see them a little better and be able to differentiate between the two. But a long line is 10 knots. A short line is 5 knots. And if there happens to be a flag on it, that's 50 knots. And then you just add them all up. Long line, short line, flag. All right, just add them all up. So for this example, the wind's out of the southeast at 15 knots. And then you can see the G25 at the end of the barb. That means it's 15 gusting to 25 out of the southeast. Okay, in the center of the plotted Meetar, that circle that you're looking at here may not always just be a circle. It could be filled in, but what it's telling you and what it's talking about is the cloud coverage over a particular spot. So if you've got just the circle there, as you see in my example, that means that you're either going to, so the way this is measured, if you have an observer that's at the airport, not every airport has an observer, a lot of it's just done automatically with the surface observations or with the equipment. But if you actually have an observer there, they can go out and they can tell you it's how many octets, O-C-T-E-T-S, octets of clouds that are in the sky. They kind of divide it into 8 pie pieces. So if you see a clear oval in the middle or a clear circle in the middle, that means you've basically got a clear sky. And that's 0 to 1/8 octets of cloud cover. If you have just a quarter of the circle filled in, that's scattered, or SCT, and that's 2, 3, or 4/8. And then if 3/4 of the circle is filled in, that means it's broken, or BRK, and 5, 6, or 7/8 of cloud coverage. And if it's filled all the way in, that's overcast, and that's 8 out of 8 octets. So if we think back to the raw Meetar that we saw earlier, where I had 4 different cloud covers, that's going to actually grab, what you're going to see for cloud coverage is going to be the lowest cloud deck. And I think that was few at, I think, 3,500 or 3,800 or something like that. So it would be just a clear or few falls in that clear sky category, and that's what you would, that's this open circle that you see in the middle is what we would have had. All right, Sean asked a question before I get too much further about the wind. Over how long of a time period is the gust number calculated? It's gusted at 25 in the last 5 minutes, or 35. That's a good question, Sean. Most of the stuff comes in at the top of the hour, so it's going to take an average. It's actually, I think it's a 3-minute average, but that stuff's going to come in at the top of the hour, and then throughout the hour, if it meets a certain threshold, and I can't tell you exactly what that threshold is off the top of my head, you actually, the ASOS, the automatic surface observation station, will actually send out what's called a special. So it's an observation that goes out during the hour instead of just at the top of the hour. Erica asked that question, are Metars issued every hour? Yes, they're issued every single hour at the top of the hour. But in this case of a special, once the wind reaches a certain threshold, and again, I can't remember exactly what that threshold is, or if the cloud deck starts getting below, the lowest cloud deck starts getting below 3,000 feet, which in the aviation community, that becomes extremely important. when the cloud level is below 3,000 feet and it gets lower and lower and lower, it might start spitting out these specials at different times during the hour. So yeah, that's quite a bit of data, Erica, that could be coming in. So that's actually very, very helpful for us because we do aviation forecasts at each of the airports, Clarksville, Crossville, Nashville, and at Smyrna. And it's helpful for us to be able to get the pilots out a good, accurate forecast whenever we can. Okay. So one last part that you might see in a plotted Meetar is actually going to be located here, which is this. I just put that circle in there. That's not going to be one of your icons that you're going to see, but what it is actually the ongoing weather, the present weather that's at the airport. It's going to be located where that magenta oval is that I put there. Now, I'd go through and I explain all of them to you, but these are all of the weather symbols that could go there. So I don't have that much time this evening to do that. So these are easily findable on the web, and you can go and take a look at what there's some common ones, like the rain ones are just the dots. Obviously, the little flakes or snow. The thunder symbol at number 17. That thunder symbol is up there and used in a couple of different spots. So you can learn what some of the different those are present weather symbols that are on the left-hand side of the plot. Okay, so now it's participation time, and I'm going to start picking on people here because I like to have participation just to make sure that everybody is following what we're talking about here. So let's start with almost everybody's ahead of me on this one. How about Francesca? Francesca, are you there? Can you hear me? If you don't want to participate, that's totally okay. How about Erica? Erica, is it Klotz? Can you unmute your line and then I can